Hi everyone, this video is about modeling with trig functions, and this is day 2 of our exploration of this topic. And I'm going to be completely honest with you, this question is quite a doozy. It's pretty challenging, so make sure you have any questions that you have written down on the side of your package to ask me. But also please try to be really active and present in our problem solving here. Also, you will probably want to write small to fit everything in on this one page. Okay, so it tells us right here that Jack and Jill ride a Ferris wheel at their local fair. The wheel has a 26-meter diameter, so that's helpful. It turns at 2.5 revolutions per minute, with its lowest point 2 meters above the ground. If Jack and Jill begin their ride 3 meters above the ground, so that's when they begin it, and their height is initially increasing, then question A says to determine the equation to model their height above the ground as a function of time. So for starters, I just want to draw kind of like a rough sketch of what's happening here. So we know that the lowest point is going to be 2 meters above the ground. That's what this says right here. So if I were to look at the height right here, so we'll label this H for height, just a rough sketch. We know that the lowest point that we are going to reach is at 2 meters. Okay, so we know that this right here is going to be our minimum. And then we also know that the diameter is 26 meters. So we also know right here that 26 above 2 will bring us to our maximum. So that tells us that our maximum is going to be at 28. So I want to find the axis first. So to find the axis, I'm just going to average the minimum and the maximum. So we know that at 15, we will be at our axis, okay? All right, cool. We also know, though, that this time they're going to begin their ride 3 meters above the ground. So we know that they're going to start their ride 3 meters above the ground, and then their initial height is, and also that their height is initially increasing. So it's not going down to the minimum and then coming back up. It's going right up to the maximum right here. So we know that it's going to look like this. And then after this right here, this is when we complete a full cycle. Or we could look at it like this. We could just continue this right here. And we know from here to here would be a full cycle. Also, because the axis is 15, we can see here that the amplitude is 13, because the distance between 2 and 15 is 13, 15 to 28 is 13, or I could subtract 28 and 2, divide by 2, and I would get an amplitude of 13. All right, cool. So we know that A is 13 and C is 15. That will be helpful to us. We also need to know the period to help us find the K, and then find the phase shift, which is D. That's the tricky part. Okay, so for the period is how long it takes to complete a full cycle, right? And it tells us right here that they're going at 2.5 revolutions per minute. So in this period right here, we know that in 60 seconds, they go 2.5 revolutions. Well, what if, and I'm changing this to seconds just because it's a lot easier of a number to deal with in terms of what our period would be. If you want to stick with minutes, that's fine. It actually gives you an easier looking K value, but it's a little bit harder to deal with later on in this problem. So for example, if I told you that in 80 seconds, the wheel went around 4 times, we had 4 revolutions, that would mean that we would have 20 seconds per revolution, right? It would take us 20 seconds for every revolution. So here, to figure out our period here, I would divide 60 seconds by 2.5, and that would tell me that it would take me 24 seconds per revolution. So that would be my period. Well, if my period is 24, then the K value is 2 pi over the period, So that means that my k value would have to be 2 pi over 24, which when I reduce it would be pi over 12. Okay, so here our k value is pi over 12. So we have everything we need, A, C, and K, except for D. And this is where things get really tricky. So we need to solve for D. Well, for starters, we need to decide which type of function we're going to use. Whether we're going to use sine or cosine, negative sine or negative cosine. I think I'd prefer to use cosine, mainly because if you take a look at this graph right here, the axis is at 2. So this right here is really close. Like this starting point of 3 right here is very close to our minimum value. Sorry, not our axis, our minimum value of 2. And our minimum is always going to be negative cosine. So I think I'd rather just do that right here. And I know here, like if I were to extend this right here, this would give me a D value. And by looking at our graph here, since this is 0, we know our D value is going to end up being a negative number. So let's actually go ahead and do this. So the height in terms of time is going to be equal to the A value here, which is 13. But because we're starting at the minimum, I'm going to say negative 13 times the cosine of, the K value here is pi over 12 times X minus whatever the D value is, which we don't know. And then I'm going to say plus 15. Well, the only way that I can actually figure out what this is going to be is by subbing in a coordinate that I know. And the only coordinate that I know is this y-intercept, this starting point. So I'm going to sub in 0, 3. So instead of h of t, I'm going to put in a 3. I'm going to copy everything else down exactly how I see it. So negative 13 times the cosine of pi over 12 times 0 minus d plus 15. Well, we know that 0 minus d right here is just negative d. So we can rewrite this as 3 equals negative 13 times the cosine of pi over 12 times negative d plus 15. Okay, so I'm going to isolate this cosine to make my life easier. So I'm going to subtract the 15. I get negative 12. Then I would divide both sides by negative 13. I get a positive 12 over 13. And normally I would find my related acute angle at this step. However, cosine is already positive, and I only need the first answer because the first answer is going to give me the D value. So I only would need like the quadrant 1 answer. I wouldn't need the quadrant 4 answer because that would be right here at this point right here, which I could actually use if I wanted to, but that would be extra work because I'd have to find the related acute angle first and then subtract that from 2 pi. So I'm not even going to bother doing any of that. But I am going to do this to make things easier for me. I am going to let U equal this angle right here. Because once I do that, it's so much easier for me to deal with solving for the angle. So to get that U alone, I have to do the inverse cosine of, so we'll say U equals the inverse cosine of 12 over 13. So then U would equal approximately, I'm going to type in the inverse cosine of 12 over 13. So U would be approximately 0.3948. Well, if U equals pi over 12 times negative d, then I can say pi over 12 times negative d would be equal to approximately this 0.3948. So in order for me to solve for d, the first thing I would do is multiply by 12 over pi to cancel these out right here. And then I would also multiply by a negative to cancel out this negative right here. So then that would just give me that d equals, and then I'm going to do the same thing on this side. So I'm going to multiply by negative 12 over pi. Now, I'm trying not to round quite yet. So like I rounded when I wrote down my answer right here. But if I actually set this equal to u, and again, if you want me to show you how to store variables in your calculator, I'd be happy to help you out with that in class. And all I want to do is take my u value and multiply that by negative 12 over pi. So that means here my d value would be negative 1.508. So d equals approximately negative 1.508. Well, now that I know that, I can go back up here and I can just rewrite my equation right here. So here, that means that my equation would have to be h of t is equal to negative 13 times the cosine of pi over 12 times x minus negative 1.508. So x plus 1.508 plus 15. So here is my equation for part A. Now, before I go on and move on to part B, I just want to set this equal to D right here. And I actually want to graph this out to confirm that this actually worked. So I'm going to just change my scale right here. I'll go up to like 48 because I know that the period is 24. So I want to be able to see like at least 2 cycles. I also know that my lowest value is 2. So I'll go from 0 to, and I know my highest value is 28. So I'll go to 30 and I'll go ahead and type in my equation. So I'll type in h of t is equal to negative 13 times the cosine of, now listen to this part right here. I'll type in pi over 12. And then when I get to my x value right here, I can just type in x minus d instead of x plus 1.508, because then it'll use this actual value that I have here. And then I can say, oh, I got to be consistent. If I'm going to use h of t, I got to put a t here. And then I can say the plus 15. Okay, so let's take a look at what's happening here. So for starters, I better see that it starts at 0.3, and it does. It starts at a perfect 0.3. If you use the rounded answer, it might not necessarily show 0.3. And I also want to just show you the intersection point between this right here. So after a full complete cycle, we're at 24.3. So we can see here that a cycle period is definitely 24 seconds. Okay, so question B says, Mary lost her little lamb. If Jack and Jill are high enough to see Mary's little lamb, when they are 20 meters above the ground, for how many seconds can they see the lamb in one cycle? So pretty much what's happening here is we have they're at a height of 20. Just want to know how long it's going to be from here to here. How many seconds is this going to be? So like, for example, I'm just going to give you random numbers. Let's say this was at 5 seconds. This was at 12 seconds. The answer would be 7 seconds because the difference between 5 and 12 is 7. But the question is, what are these x values? We don't actually know what these x values are, so we have to solve them. So here, our height would be equal to 20. So I'm going to sub in 20 into my equation right here for h of t. So I'm going to isolate the cosine. So I'm going to subtract 15 from 20 and I get 5. And then I'm going to divide by negative 13. So I get negative 5 over 13 is going to be equal to the cosine of this really ugly expression right here. But now that I've done that, I'm going to actually want to go through right here. And I want to set this equal to u, but u is already taken. So instead of u, I'm just going to use v. So here we're going to say let v equal pi over 12 times x plus 1.508. Okay, so right here, what we're trying to do is solve for negative 5 over 13 equals the cosine of v. Better write smaller. So, and the next thing that I need to do is I need to find my related acute angle. And I'm going to call that beta. So I'm going to say 5 over 13 is equal to the cosine of beta. So that tells me that beta is going to be equal to the inverse cosine of 5 over 13. So let's go ahead and type that into our calculators and see what we get approximately. So type in the inverse cosine of 5 over 13, and I get another super ugly number. So we'll write down that this is approximately 1.176, but we're still going to use the actual value in the calculator. Okay, cool. So now cosine is actually a negative value, and because cosine is negative, we have to think about which quadrants cosine is negative, and it's always going to be the left two quadrants right here. So quadrant 2 and quadrant 3. And we figured out right here what that beta is, right? So we know that beta is that 1.176 in radian measure, right? So to find our first v that we have here, our first v is going to have to be pi minus beta, right? So it's going to be pi minus approximately 1.176. And this right here is my first v, so I'm going to call this v1. So v1 is going to be approximately, so in here, what I'm going to do is I'm actually going to call this answer here b for beta. And then here, I'm going to put in pi minus b, or pi minus beta, and I end up getting 1.966. So then, because v is equal to pi over 12 times x plus 1.508, I can replace that right here. And that's going to equal this 1.966. So in order for me to solve for x, I'm going to multiply both sides by 12 over pi to get that 12 over pi to cancel out. Okay, and then I'm going to subtract this 1.508. So that means that my first x value right here is going to have to be 1.966 times 12 over pi minus this 1.508. Okay, and just a reminder that right here, this is what positive d is, because d, we figured out, is negative 1.508. And so since this already says negative 1.508, this is plus d. So I could type that into my calculator, but it's not going to be as accurate as if I were to do the following thing. So here, this is what v was. And to get that v value, what I did is I took that number, that 1.966, I multiplied that by 12 over pi, and then I added d to that. And that would give me 6, like a perfect, even, beautiful 6, which is just a coincidence that it ended up being a perfect answer here. So here, x1 would equal 6. Well, I need to do the same thing for v2, right? So right here, we can say that v2, let's just put this down right here. To find our second angle, this time it would be pi plus beta. So v2 would be pi plus beta. So v2 would be equal to, so what I'll do here is I'll actually change this to pi plus beta. So pi plus b. So this right here tells me that my v value would be 4.318. So v2 is approximately 4.318. But just like we did before, we're going to set this equal to pi over 12 times x plus 1.508, because again, that's what V is. And then I'm going to say this is equal to 4.318. Now, you can go through and just get to write to this final answer right here. Once you've done it once, you don't have to do it again, but I'm going to do it again just for the sake of like understanding what's going on right here. So same thing here, I'm going to multiply by 12 over pi to cancel these out. Whatever I do on one side, I have to do on the other side. So I end up getting right here, so these are gone, right? So this 12 goes away, this pi goes away. So I end up getting x plus 1.508 is equal to 4.318 times 12 over pi. Now I need to subtract this 1.508 over, so x would be equal to 4.318 times 12 over pi minus 1.508. And the beautiful thing about Desmos, or storing anything into your calculator, is I've changed this v value to pi plus b instead of pi minus b, and it automatically changed my answer right here to about 15 seconds. This one didn't end up being a nice, pretty even number. So x2 is about 15 seconds. But the question is asking you for how many seconds can they see the lamb in one cycle. So they first see the lamb at 6 seconds, and then they see the lamb again at 15 seconds. So they see it for a total of 15 minus 6, which is 9 seconds. So therefore, Jack and Jill can see the lamb for 9 seconds in the first cycle. Let's verify that this is right. So as always, Desmos is amazing. I can just type in y equals 20. If I look at that right here, my first time that 20 happens is at 6 seconds. The second time that 20 happens is about 15 seconds. So that means that this right here is going to be a total of 9 seconds in between these two values right here, okay? All right, for question C, it says to determine a time in the first cycle when Jack and Jill are moving the fastest and find their speed. I'd like to talk about that with you in class. Also, I think this video might be getting a little bit too long, so I will spare you and we will talk about this in class hopefully pretty quickly. You do not have to do anything with question C in preparation for class though. All right, thank you. That's it. Let me know if you have any questions and I will see you in class. Bye.